Good day. We carry on our look at comparing the strengths of oxidizing agents so that we can get a table of reduction potentials, and then we can use that table to interpret other questions. So this one will be a little more complicated than the last one, but basically the same process. We are on to number 19. So here we're given the first reaction, so that's no problem. And the other ones we have to figure out what's going on. But these are all going to be redox reactions. And so hopefully I've copied them out correctly from your book. Anytime it's no evidence reaction, we got to figure out what the products would have been, and we flip the arrow around because it means the stronger oxidizing agent was on the right and it's pushing the reaction left. So the first question, what we have to realize is we have Ag plus here and we have Br minus there, and I should put a plus there. That was important. So Br2 is stronger than Ag plus because this silver was 0, now it's at 1 plus and the Br is 1 minus there. Hopefully I haven't butchered that later. Now we look at the next one. Oh, it's going to be Agi. So Ag plus is on this side and we have the I2 there. Comparing those, Ag plus is stronger than the I2. And you can see I haven't bothered balancing it. That did not matter. Now in this one, I had the Cu2 plus and I minus. Cu2 plus reduced down to Cu, and I'd be getting I2. And when we look at this, I2 is stronger than Cu2 plus because it drove the reaction to the left. There was no forward reaction. And I think you'll find this is a little bit more confusing than the previous one, but just do your best. So now I figured out that when these go together, and you can see I didn't balance it, we can balance it, that's not too critical. We really just care about the strengths here. Cl2 is in the higher oxidation state compared to Cl minus, and it outpowers the Br2. Well, once I've done that, I can see that I have a lot of information. So I look at this and I go, okay, what is the strongest thing here? Well, there's Cl2 outpowered Br2. And then I see the Br2 outpowered the Ag+, the Ag+ outpowered the I2, and the I2 outpowered Cu2+. So you just go along with those 4 pieces of information to put the 5 chemicals in the right order. And notice these you may say, oh, they don't have positive charges. Well, they're lower oxidation states than negative. Whereas the metals, we got the positives because their higher oxidation state will be positive for a metal. Once you've done that, you got the question beat, because all you do is you write that information out in this order: Cl2, Br2, Ag+, I2, and Cu2+. Strongest oxidizing agents here, strongest reducing agents there. Now some of you are saying, well, I could have just looked this up on the table of reduction potentials, but often I will give you questions involving chemicals that aren't on that table. So you have to be able to do this process. But now we have our own handy-dandy table made, and we're going to ask you some questions, and these should be easy. Would I2 and Br minus react? Here's I2, there's Br minus, they're diagonally like this. This is higher than that, on the right is left, higher than the left. So that is a definite no, that's a non-spontaneous. It says, would Cl minus and Cu2 plus react? Well, again, the Cl2 minus, or Cl minus is higher than the Cu2 plus, so that's a definite no. Would Cl2 and Cu react? Cl2 and Cu are positioned like that, and that's a definite yes. Now, when we look at these, the Cl minus and Cu2 plus and the Cl2 and Cu, well, those are reverse reactions. So if this reaction doesn't happen, flipping around, the other one has to happen. So a lot going on. You may want to watch this video more than once, because I think as you go through it, things will make more and more sense.